Hi there. Welcome to another video. And in this video, we're going to be talking about how to do semantic search on structured and unstructured data and how payload indexing helps in improving the semantic search. Also, I'll also be talking about how we can do all this using Qdrant as well. Okay, so if you've clicked this video, I'm very sure you already know what semantic search is. So we'll not really be talking about that. Let's just talk about the structured and unstructured data. Now, structured data um, are organized data, and this is what adds like control or filtering during a semantic search. So examples of this data could be a timestamp or the severity of the severity of a service or an environment, etc. So these data are known as metadata. They are what gives control and filtering, which we'll talk about much later. And unstructured data is what offers context. It is what we use as embeddings during a vector search. So these data are like unorganized data, like let's say a chat history, support tickets, readme files, or incidents report of a service that broke when a user was trying to perform an action. So when you combine the structured and unstructured data in a semantic search, it helps you find vectors with so much precision. So in a semantic search without filtering, you just get to see vectors that are nearest to your query vectors. But it doesn't really mean that every single vector that you find is important to that query vector. But when you add filtering, or when you add the payload or metadata, you get to filter and you get to actually see vectors that are really important to your query vector and that are meaningful as well. Now that we know how structured and unstructured data work together, how does Qdrant handle semantic search? Now, during a semantic search, Qdrant uses the unstructured data as the vectors, as I said earlier, the vectors for the semantic for the vector search, or for the or during the semantic search, and then they use the structured data as payload. And now this payload are usually indexed separately so that filtering can be applied during the semantic search. I have a Google Colab code here, so we can just walk through the code version of everything I just said now, so that you see like a practical example of it and not just the theory part of it. All right, so this Google Colab would be shared in the video description, so don't worry about this and just focus on understanding the practical example of what I just tried to explain. Okay, so this is okay, so the goal of this practical example is to show how Qdrant perform a semantic search across both free text documents, that is the unstructured data, and structured tabular data using payload indexing. Okay, today I would not really be talking about custom scoring logic, because I feel like that's something I still need to dig deeper and understand before I talk about that. So hopefully in the next video I will be able to talk about that. Okay, first of all, let us install Qdrant client. So we'll be using the fast embedded, which is a very lightweight embedding library by the Qdrant team, and that's what we'll be using to handle any sort of embedding in our semantic search or in this project. And okay, yeah, and we've seen that fast embedded has been installed alongside other important packages that we would need in this project. So next thing, we'll need to import libraries and packages. So we would be importing the Qdrant client and models from the Qdrant client that we installed, and would also be importing text embeddings from fast embeddings. I'm sorry, from fast embedded that we also installed earlier. And this from Google.Colab imports user data is how we are able to manage our API keys or our private keys that I really don't want to share with the public. So all you just got to do is click on this key icon, and you should be able to add the name of your secret key and the value, and you have to click you have to toggle this notebook access so that you can actually use it on your notebook. If not, you may not really be able to use that on your notebook. And then once you have added that, you can just define it like this using the user dot data and the name of your secret key. Okay, so for us to create sorry, for us to initialize our Qdrant client, we need to pass the URL and the API key to the Qdrant clients, and then we need to define our text embedding. And the model that we are using is the BAAI model. This is a very, very lightweight model, and I think it's perfect for this demo project. Of course, there are so many other text embedding models that you can try. Yeah, there are so many other text embedding models that you can try. I'll probably look for an article that talks about more on text embedding models and add that to the video description to give you more resources on this if you are thinking of building if you are thinking of implementing this on like a hobby project and you don't want to use a very simple lightweight text embedding like this. And let us set it up. And we see that we have successfully set up our Qdrant client. Yeah, so the the embedding dimension for the text embedding that we're using is 384. So this is very important, and we would talk about that much later. So after the setup, we'll need to create a collection. Now, what exactly is a collection in a vector database? I'm still very sure a bunch of you already know that, but in case you don't know that, think of collections are like rows in a database. Unlike your traditional like SQL or NoSQL database that stores information in text, a collection stores the embeddings of a vector database. Now, in our collection, we would be defining this this 384 embedding dimension. That's what we'll be using as the vector size, and would also be using the embedding model as I said earlier, and that's what we'll be using for our vector configuration for the collection. And yes, would also be using the cosine similarity, which I would love to explain in a separate video, like really what is a cosine similarity, and what other similarities do we have when we are dealing with vectorization. Okay, so this is just a very dummy data, and this dummy data are a bunch of support articles, and we can see it has an ID, a title, the body, product, version, difficulty, tags, and last updated. And it's just like billing and analytics and a bunch of other things. I think password reset too is also here. So yeah, that is the data. And for us to create a collection in Qdrant, we will need to get the embedding size, and would use the embedding size to define our vector configuration. So we say client dot create collection, and then we define the collection name, which is support articles, because these are like a bunch of article these are a bunch of articles about a platform also. And then we define the configuration, the vector configuration, and in the vector configuration, we'd use models of vector params to define the size. I'm sorry, would pass the size and the distance, which I said we will be using the cosine distance as our vector configuration. And once we click this, we should see that the collection has been created. So you can head on to your Qdrant collection. I will just refresh my page and I should be able to see the support articles collection has been created, but no point or no data or no embedding has been sent to this place because we haven't passed it. All right, so the next thing is to ingest the document, that's to ingest this data set. And for us to ingest it, we would have to extract the ID from the document ID, and then would have to convert the whole document into vectors. So we are taking every single data set here, we are passing them through an embedding. It text embedding, the one that we defined earlier on, and that's what we are using as the vector. And then we are also adding a payload, which is the metadata. We are adding all this as points in our Qdrant collection. So we're just going to run this and we see that the document has been ingested. The vectors are the title and the body, and then we now have structured payload as well. So if I go back to my Qdrant collection and I refresh it, you should be able to see this. So we can see that this is the payload and we see like vectors. Okay, so we see that we've been able to ingest the document as points into our Qdrant clients. Okay, now let me show you how we can do semantic search without filtering, and then I'll also show you how to do it with filtering, and you should be able to see how these two differs, like in a very slight but meaningful and important way. Okay, so for us to do a pure semantic search, would have to get the would have to pass our query vector. Sorry, we'll have to pass our user query, which is upgrade from basic to pro. We'll pass that to an embedding model, to convert the text to vectors. And then we are going to use query points, which is a way for us to query the points in our collection. And we are going to pass the name of the collection name, which is the support articles. We'll pass the query vector and we'll pass a limit. So what we are trying to do is we are querying the points. We are querying the points in the support article collection and only returning 5 vectors that are similar to our query vector, and then we are printing that out. And this is how and this is the result of our pure semantic search without any sort of filtering. And the user query or the query vector was about upgrading from basic plan to a pro plan. And in the return vectors, you can see that the first vector was about upgrading your plan from basic to pro, which is important. Updating your payments method, important too. Subscription downgrade process, important too. Change your subscription tier, which is still all related to billing. And lastly, we see something else: fix dashboard performance issue. Mind you, this last vector has nothing to do with billing, and right now our user is strictly asking us something about billing. So why are we seeing dashboard performance here? Why are we seeing something relating to user performance or analytics? Now, this is what sometimes happens in a pure semantic search, where you get vector that has nothing to do with your query vector. Now, for you to improve that, this is where payload in indexing comes. So we get to use the unstructured, we get to use the structured data, the metadata, the additional data to filter our vectors, and we only get to return only important and meaningful vectors that are strictly related, or yes, that strictly nearest to our query vector. So before we perform the whole payload indexing and filtered search, we'll first of all need to create a payload index in our Qdrant collection. First of all, we need to create payload indexes in our Qdrant collection, and we want the indexes to be around products, version, and difficulty, which, as you can see here in our pure semantic search, we should see the product here, which is billing, we should see the version, and we should see the difficulty. So when we create the payload index around these three fields, we get to perform a more filtered search. Hence, that was why I decided to use the fields product, version, and difficulty. Now, for us to create the payload index, we just have to use create payload index. This is a Qdrant function, and we need to pass in our collection name, because as you can tell from earlier, I do have like three collections in my Qdrant, and right now we're only focusing on a particular collection. So hence we pass the name of the collection, we'll pass the field names, which is what we have defined up here, and then we'll pass the field schema. And the reason why we decided to go for the keyword schema, the keyword payload schema type. So the reason we went for the keyword payload schema type is that this is perfect for exact matching, rather than full text payload in indexing. We just want to get the exact match based on this field. So once we click on this, we should be able to create our payload indexes. So we can see that we've created product, version, difficulty. And when I go to info, I should be able to see my payload schema right here. And we see that, and we can see the difficulty schema, which is a keyword. The same thing with the version and the product. So we can see that we've defined our payload schema, and with this we can start doing our payload indexing. And next, let us perform the semantic search with the payload filtering. So the only difference is that this time around we are going to be doing a more filtered search, where we would target the product keyword or the product payload, and find the values of the vectors that match exactly to the product payload or the product's keyword. And then we will now add the query filtering here, and then would also do with payload equals to true, because we are we are adding a payload. Now when I redo this, you should see that we get almost the exact same vectors returned, except one thing. In the last one, we saw that the last vector was about fix your dashboard performance issue, which has nothing to do with billing or has nothing to do with subscription. But we see here that the last vector here had to do with billing invoice history. And essentially every single vector here now has to do with billing and strictly on billing, because what the user is asking for is on billing. And we even improved our search query by adding the products that we want by adding the products that we want to search for. So we strictly search on solely on billing. And this is how payload indexing or payload filtering can really help improve your semantics, can really help improve a semantic search, where you get to not only return the nearest vector to a query vector, but you also get to return relevant vectors to that part, to your query vector. In the next video, I would love to cover on creating a custom scoring logic on this semantic search, but I still need to do more research and really understand that, so I don't get confused by explaining that. But regardless, this is everything I know so far on payload filtering in a semantic search. So if you found this interesting, or you learned a thing or two, you can leave a comment, like, and subscribe to this channel, because I will be creating more videos on what I learned. And so far I'm learning a lot of concept around vectorization and related topics. So until the very next video, see you next time.